way of looking at energy cycle. So let's take a look at concept number 4 together. This is your Hess's law, which is energy cycle. Let's take a look what it means by the word Hess's law. Hess's law simply means that the enthalpy change of a reaction is determined by the initial and the final state of the system and is independent of the pathway taken. What does it mean? I give you an example. Take a look at this equation here. Take, for example, if you want to convert A plus B to give you XY. This is one enthalpy change of reaction, which means this is one way I can convert to X plus Y. But this is not the only way. The other way I can do it is I convert A plus B to C, C to your D, and D back to your X plus Y. So they are saying that using Hess's law, it doesn't matter you go from A plus B to X plus Y directly, it is also the same amount of energy change as you compare to A to B, C, C to your D, and D finally to X plus Y. I can give you one analogy. Let's take, for example, here. This is your school. Maybe this is your school. School is on the right-hand side. Huh? This is your school. This is your home. You want to travel from your home to your school, there are many methods. One, you take by taxi. This is taxiway, straight reach the school. Second way, you're a bit more hardworking. So you walk to the bus stop. What do? Then you took the bus. Then what happened? Then you walk to the school. Do you reach the same destination? Yes. They are independent of each other pathway. This is what Hess's law is trying to tell you. Now, I want you to make use of this information, the independent pathway. Focus on the arrow. You see there's an arrow here? This arrow is converting A plus B to X plus Y. This is like going in a clockwise direction. So I call this as a clockwise energy. Clockwise. Take a look at the one below. Do you see that the one below, A to C, A, B to C, C to your D, D to your X plus Y? What do you notice? This is a anti-clockwise energy. Now, how can we make use of clockwise equals to anti-clockwise? Do you recall just now what we learned before? Heat release equals to heat absorbed. This is the same thing. This is also using heat release equal to heat absorbed. Just that we don't know who is heat release, who is heat absorbed. I can randomly say that maybe your clockwise is the heat absorbed. Then your anti-clockwise will be heat release. And what must it become? They must be exactly identical. So that means clockwise can be heat absorbed, anti-clockwise will be heat release, or vice versa. Let me use another example to illustrate this point. Take a look on the right-hand side. We can take a look at M plus N to QR. This is clockwise energy. Then this is another one. This is your anti-clockwise energy. Like I say, it doesn't matter who is heat release, who is heat absorbed. It doesn't matter. This time now, I can say that this is heat release. This guy will be heat absorbed. As long as you always equate heat release equals to heat absorbed, you can complete the entire system. So this is consistent to what you learned in concept number 3. And now, we're going to use this information and solve energy cycle questions. Remember, clockwise equals to anti-clockwise. Let's take a look at the next page. So we will take a look at one word example together. So for those of you who always find that energy cycle is very confusing, follow me along the way, temporarily disregard or maybe forget what you learned in school for the moment. Later then you just remember that. So I have given the data below. I need to construct an energy cycle and calculate the enthalpy change of the reactions for here. So I'm going to copy down this entire equation below. So let me show you. 2 carbon solid plus 3 hydrogen gases plus half oxygen gases and give you C2H5OH. Now our goal is very simple. find the enthalpy change of this reaction. That is what they want us to do. Now, we are given some information. You see the enthalpy change here got a subscript C. What does C represent? Combustion. Now let's recap again. What is the meaning of enthalpy change or combustion? This is very important because you don't know the definition, you can't solve it one. So let me just revert directly to the definition. You just bear with me for a short while. Combustion means what? One mole of a substance. Who is the substance? The reactant. So be very careful who is the one that is burned. Not anything, It's a reactant burn in excess oxygen. Let's take a look carefully with the example below. You have a CH4 with oxygen, give you CO2 and H2O. This is your reactant. Is this 1 mole